Welcome back to the basement math lab. Today we're going to do SOH CAH TOA, and this is a part of trigonometry. Now SOH CAH TOA is something that can only be used with right angle triangles. So if your triangle does not have one right angle in it, you can't use this at all. This is not applicable. And you'll see that something is a right angle triangle if it has this little square mark on one of the angles. And that is basically a sign that indicates that that side is a right angle. So we've got two triangles here. And we're going to go over what SOH CAH and TOA mean. So for this first question, let's solve for this angle. This is our angle theta. Okay? So that's the angle that we need to solve for. And you see over here, you can do sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Now what this all means is that you see this angle. Now the opposite side of it is the side that it is not touching. So that would be this side. That is the opposite side because you see this side and this top side they make the angle. So it's the side that doesn't make the angle that is the opposite side. Now the hypotenuse is always the side that is opposite from the right angle. See, this line and this line make up the right angle. Now the line that doesn't make up the right angle is the hypotenuse. So we can just label that hypotenuse, and let's just label this opposite. And now the last side is the side that is adjacent to the angle, so we will name that adjacent. Now if we want to find the sine, or if we want to find theta, we are going to have to use either SOH CAH or TOA. Now we need to have two values that we know if we have one unknown. And the unknown is this theta. And now the two values that we have are the length of the adjacent and the length of the hypotenuse. And the one thing that is adjacent over hypotenuse is cos theta. So over here, I will write down cos. I'm just going to pause and then show you after. So cos theta is equal to adjacent over hypotenuse. And now we can sub in the values for the adjacent side and the hypotenuse side. The adjacent side being this 4.5 meters and the opposite side being this 12 meters. So I'll just sub that in. So here we have the 4.5 and the 12. From this, you could put in meters or not. This is just a practice question, so I'm not going to. But for future, you will have to put in the units. Now, when you have something like this, what you do, you get your calculator, and I'll just do a quick cut to show what the equation is. So you would do 4.5 divided by 12, and the answer would be 0.375. So, over here we have cos theta is equal to 0.375. But what is the measure of the angle? Because the angle is surely not 0.375. Well, that's where you have to take a different direction, in which you use the second function and the inverse cos sign here. So if we just clear that, and we go with the second function, and then inverse cos, and then we put in 0.375, like that, and then close the brackets, we will get 67.9, which we can just round to 68 for the example at least. So 68, whoops, that is a 0. 68 degrees. And now another way that you could do it if you don't want to do two steps and you want to get a more accurate answer you can go inverse cos of 4.5 divided by 12, like that. And then when you enter, you get the same number. And this is just a better way, because sometimes when you do the fraction over here, you're not going to get a decimal that stops. And it'll just go on for a long time, and you don't really want to write all of that. So you could have this, alternatively, the inverse cos of the fraction. And so that's cos. Now, let's do with sine on this triangle. And I know that it's sine because I made this. And so we have the theta here. And this is actually incorrect for this example. Because if we're finding for this side, we can just cross that out. This is no longer the opposite side. It's actually the adjacent side, because it makes up this angle as well as the hypotenuse. So this is the side that actually doesn't make up the angle that we're trying to find. So we can just erase this and put an opposite like that, and then we can erase this and put adjacent there. So you have to adapt to every single triangle that you get. And so now I'll just write in the sine equation after. And here we have sine theta equals 4.5 over 12. And you might be wondering, we have the same thing before. Over here we also have 4.5 over 12. But sine is different from cos, so we're actually going to get a much different answer. So if we go here, clear it, sorry. And then we go to our second function, and we do the inverse sine, because we have to do the inverse sine to get rid of the normal sine. And we do 4.5 divided by 12. Like that. And then we can just move it over a little bit so you can see. And then when we press equals, we get 22. So theta would equal 22 degrees. And that would be the angle measure for that. Now, I'm going to do an example with tan, except this time we're going to be solving for a side length rather than an angle. So over here on this triangle at the bottom, let's say that we are solving for this side. Hold down the paper. Okay. We're solving for this side, right? Now, we have the angle and we have the opposite side. And we're looking for the adjacent side. And so what is opposite over adjacent? Tan. And since we have an angle, we actually don't have tan theta or sine or cos theta. We actually have tan 35, and then we have a variable for whatever the adjacent side is, and then the opposite side. So I'm just going to write out the equation really quick. So here we have the different equation, and we put in 35 here because that is the measure of the angle. And now we're actually solving for x rather than theta. So if we want to rearrange this equation, you could do it on your own, but basically you're going to be multiplying both sides by x and then dividing both sides by tan of 35. So really quick, I'll just show what the arranged equation looks like. And here we have it, x isolated on one side. And so now all we got to do is we just go into our calculator and we press clear from the last problem, and then we go 10.2, and then we divide by the tan of 35. And we don't need the inverse tan for this because we're not isolating x. You see, over here we were isolating theta on its own because sine was happening to the theta. But now, nothing is happening to this x, it's completely on its own, so we don't need any inverse tan. And so when we press equals there, we get 14.56. And now if we round that to one decimal place, that would be, let's say, 15 meters. So x would be equal to 15 meters. And so this side would be 15 meters. It's obviously not drawn to scale, this triangle, but most triangles aren't really drawn to scale, so that doesn't matter. And so that's how you use SOCA and TOA. Basement Math Lab out.